All right, so let's take a look at this question here. Now it says Antonio likes to go to the local carnival. So for a certain game, the probability that Antonio wins is K. Antonio decides to play the game 18 times. Okay, so part A says write down an expression in terms of K for the probability Antonio wins exactly 8 games. Okay, so the first thing we need to do is recognize this is a binomial distribution type question. All right, thinking back to those 4 requirements of binomial distribution. Okay, so we have, first of all, let's define our x. In this case, it would be Antonio. He wins the game, right? So Antonio wins. That's our definition. The probability of this happening, they say, is K. So the probability of this happening is K, right? So our binomial distribution parameters, the number of trials, it says he plays 18 games. The chances of him winning, right, is K, right? So we have our parameters for the binomial distribution. Now in part A here, it says write down an expression in terms of K. So in terms of K means that our answer should have K in it. Find the probability that Antonio wins exactly 8 games. So the probability that he wins, so X represents Antonio winning, is equal to 8, all right, exactly 8 games. Now, like I said before, the more challenging and complex binomial distribution questions will require you, right, to use the binomial distribution formula where you expand out what's happening. So that's what we need to do here. So we set up our parentheses. This is going to be our number of trials, 18. This represents success, in this case K, all right, some value we don't know yet. And failure would be 1 minus K, right? And then X is equal to 8, so success, so he's going to win 8 times. So that means he'll lose 10 times. These have to add up to 18. And you could put either 8 or 10 here. It doesn't make a difference. Okay, so this expression would represent, right, Antonio winning exactly 8 games. Okay, part B, take a look at part B here. The probability, write down an expression in terms of K for the probability Antonio wins at most 2 games. So at most 2. So that means he can win 2, 1, or 0. Okay, so X is less than or equal to 2. So we expand this out. So you have to understand this represents X might equal 0, right? Plus X might equal 1 plus X might equal 2. So we have to expand this out and show all the values. This would be 18. This is K, 1 minus K. This would be 0 here, so he never wins. So you could put a 0 here. So that means this would be 18 here. He always loses. Plus, we have 3 parentheses here. We have 18. We have K, 1 minus K. So he wins 1 time. So this would be 1. This would be 17, right? You could put 1 here. And then plus, we have him winning twice. So this would be K, right? 1 minus K. So if he wins 2 times, he's going to lose 16 times, right? Put 2 here. So this would be an expression, right? Kind of written out in terms of K, right? For Antonio winning at most 2 times, right? At most 2 times, right? And then let's take a look at the last example. Let me go and erase this real quick. Part C. Part C says, find the values of K such that the probability that Antonio wins exactly 8 games is 0.172. So part C here, we're just going to use the formula that we already have from part A, because this is when he wins exactly 8 games. We need to set that equal to 0.172. All right, so basically this right here. So in part C, we have 18, choose 8. We have K to the 8th power times 1 minus K to the 10th is equal to 0.172. Okay, now we need to solve for the values of K, right? So the easiest way to do that, I think, is to just set this equation equal to 0 and then graph it. Okay, so that's exactly what I'm going to do. I'm going to set this equal to 0. So we have 18 choose 8 times k to the 8, 1 minus k to the 10th minus 0.172 equal to 0, right? And then I need to know what 18 choose 8 is, so let's calculate that. So we have menu, calculate, we've got menu, probability, combination, so we have 18 comma 8 here. We need to know that value, that's 4,300, 758. So 4,300, 758. All right, so 4,300, 758. Right, k to the 8th, so k to the 8th power times 1 minus k to the 10th minus 0.172. So I'm going to graph this here, right? So we're going to use the GDC. We're going to graph it. So I'm going to graph this. So menu, see, I just graph over here. So we've got 4,300, 758. All right, times x. So use x instead of k. Exponent, that was 8. All right, times parentheses 1 minus x. And that was to the exponent. That was what, to the 10th power? Yeah, 10th power. And then minus 0.172, I believe. 0.172, yes. So we just graph it, click enter, and we're going to need to zoom in a little bit right here. We care about these x-intercepts, right? So here's our equation. So we need to find these x-intercepts right here, right? So these negative values we can ignore. That doesn't make sense. So let me zoom in a little bit more. So maybe right here we care about these, okay? So I'm going to find all these x-intercepts. So we got this value here. We've got this value right here. And we've also got this value over here. Okay, so it looks like we've got 3 possible solutions. All right. Now, if k, all right, if k represents a probability of success, right? So you notice our solutions here, one of them is actually more than 1. We know that probability is always between 0 and 1. So there's no way the probability of success right here can be 1.24. That means more than 100%, right? So we're going to reject that one. We know this answer here doesn't make sense. So our 2 solutions are 0.3976, 0.3976, right? So k is approximately 0.3976. K is also approximately 0.3976 and 0.49192. 0.49192. Right? Remember, you can always round to 3 significant figures or just keep like 5, 6 decimals. That's also fine as well. Okay? So, being a GDC question, for sure, you should be showing all this work right here. All right? Make sure you're showing all this work for part C. All right? Tell them you're using, all right, the graph. You graph this right here. And if you really want to be sure to get your marks, you could even sketch, all right, make a little sketch of this graph right here, showing these 2 x-intercept values, and that's how you got these solutions, okay?